The 2009 number one problem from the AB exam, we're given this velocity graph. Pay attention, it is velocity, and they tell you again in the paragraph, always pay attention to units. We're going from 0 to 12 minutes, and we are measuring velocity in miles per minute. And this graph represents the journey, the velocity of Karen riding her bicycle from home to school. And then part A asks for Karen's acceleration. If you're given velocity, acceleration at 7.5 would be the derivative of velocity at 7.5. And the derivative of velocity at 7.5, I don't have a function to differentiate. However, I can look at this graph, and because these are linear pieces, I can very easily compute the slope. Just be very careful, because at first glance, that looks like a slope of -1. However, look at the units in my velocity over here. That's a decrease of -0.1. My t's do increase by 1, so we go down 0.1, we go to the right 1, and my acceleration at 7.5 is -0.1. They do tell you to indicate units of measure. However, they shouldn't have, because you should always know that when units are provided, you provide units in the answer. And acceleration for the units for acceleration is distance per time squared, or in this case, miles per minute squared. Part B, using correct units, explain the meaning of that answer. I'm going to scroll up a little bit. I think this is not scrolling at all. Oh, there it goes. That was too much. Okay, explain the meaning of that integral. And I'm going to go ahead and do that part now. This integral tells you the total distance, the antiderivative of the absolute value of velocity is the total distance, not to be confused with displacement, in miles, on the interval 0 to 12. Now notice in this problem, they ask you to explain the meaning of the integral, and for that reason, I don't have to include the actual distance. I don't have to put the answer in my explanation. They do often ask you to interpret the meaning of your answer, and in that case, you would have to obviously explain the answer or include the answer. In either case, you will always need to reference any time values used. So this is the integral from 0 to 12, so you must put 0 to 12 in your explanation. So let's see, so now I need to answer this. So that integral, 0 to 12 of the absolute value of v of t dt, and just pay attention to two things. One, the absolute value will take any negative parts, any negative areas, and make those positive. So while this is below the x-axis, we will measure that with a positive value. Also, and this is something I messed up on the first time I tried to do this problem, I did notice in part A that my y-axis is measured in tenths, 0.1, 0.2, 0.3. And so that will come into play when you measure the area here. And so when I measure my total distance, my first triangle does look like it's an area of 2. However, that triangle is a base of 2 and a height of 0.2, which means the area is actually 0.2. So make sure you pay attention to those distances on the y-axis, because that will influence the areas you achieve. So my first area, I just said, is 0.2. My next area, that is negative. However, absolute value will make that positive as well, so 0.2. And then I've got all of this chunk over here, and I'm not sure how I want to measure that. I think I'll block it off here, rectangle, and then, I don't know, do a triangles there. I'm not sure. So this is an area, it looks like 1.5. However, it's going to be 0.15 when you factor in that my height is only 0.3 and not 3. This is a rectangle of area 0.3 from 6 to 7. This rectangle right here, I have 1, 2, 3, 4, 5, 6, 7, 8 there. So that's 0.8 plus I need to get that little triangle, which is a half, which we measured as 0.05. And then this triangle is going to have an area of 1, but it's going to be 0.1 because of the weird scale on the y-axis. I do not feel like adding those together, so I'm going to leave it like that, and that distance would be measured in miles. So let's move on to part C. Shortly after leaving home, she realizes she left her calculus homework at home and she turns around to get it. When does she turn around? So turning around means you are looking for the point when she changes directions. And that actually happens twice here. And you need to remember that changing direction means you need the velocity to change signs. A lot of people mistakenly assume that if the velocity is 0, then the object changes directions. You have to indicate a change in sign. So velocity changes signs. And the two places that happens, one is at a point, which is going to be the correct answer, and that is at x equals 2. The velocity does kind of change signs right around in here. The problem is there's a prolonged interval where she is stopped, and that prolonged interval, that 1 minute stopping time, indicates when she actually goes into her house to get her book and then comes back out to hop on her bike, and she resumes her trip starting over at t equals 5 to 12. And so this is going to happen at t equals 2. And at t equals 2, the velocity changes from positive, which would mean she's going to school, to negative, which means she's going back home. And I'm going to restate that it happens at t equals 2. Then we move on to part D, and here's the only part where you will need a calculator. Calculator has been allowed for the rest of the problem. So part 2, we have another person. Larry also rides a bike from home to school in 12 minutes. And his velocity is given by a function, not a table, same units, miles per minute. Who lives closer to school? Now, what you have to be careful here is in part B, when I found this integral, that was the total distance, not the net distance from school, because we do have some back and forth motion that we would have to account for. And so if you want the displacement, what we're actually going to need to measure is 0 to 12 of the normal velocity, the non-absolute value. And that one would represent Karen. And then Larry, his distance from school would be 0 to 12 of W of t. And that one I have in the calculator. That one I think was 1.6, and it is. So that one we'll just throw in the calculator and we'll get 1.6 miles. And here is where I caught my mistake the very first time I did this problem. In part B, I didn't make note of that weird scale on the y-axis. And I originally had a total distance or a net change of 15 miles. And at that point, it just seemed really weird because usually if they ask you to compare one being larger or smaller than the other, it's relatively close. It's not a huge change or a huge difference like this. So that prompted me to go back and look at part B. And in part B, instead of having 0.2, 0.2, 0.15, I had 2, 2, 1.5. And that actually ended up being 19 the first time I did it, but it should have been 1.9 total miles traveled. But you have to consider that did factor in some back and forth. So her distance from home to school, you would actually need to consider the area from 5 to 12 because that's when she restarted the journey. And 5 to 12 started right here. So I'm going to subtract that extra 0.2 plus 0.2, which would be a net change of 1.5. And since 1.5 is smaller than 1.6, that means that Karen lives closer. Whoa, where's my I? There it is. And if you want to show off, you could say by 0.1 miles. There we go. Wow, am I right? Oh gosh, what are you doing? Stop that. There. What just happened? Miles. There. All right.